A granite rod of 60 cm length is clamped at its middle point and set into longitudinal vibrations. The density of granite is 2.7 into 10 to the power 3 kg per meter cube, and Young's modulus is 9.27 into 10 to the power 10 pascals. What will be the fundamental frequency of the longitudinal vibrations? So this question is more or less based on directly on the formula itself. So we are given a granite rod and it's clamped at its middle point. So at its clamped at middle point, it will be showing something like this. So this will be our node point N, and these two will be our ND node point, and the total will be our lambda by 2. And we know that the velocity of the wave is with relation with Young's modulus. That is why it is given as velocity of wave let us suppose it is given as VW, then this VW will be equal to square root of y divided by density, and Young's modulus is given, that is 9.27 into 10 to the power 10, and it is 2.7 into 10 to the power 3 and it square root. So this is going to give us a wave velocity, that is VW will be approximately equal to 5.85 into 10 to the power 3. And next, from the figure itself, we can clearly see that this will be equal to nothing but the length. So we can say that since the rod is clamped at the middle, the wave shape will be as drawn here. So from here, the figure, we can say our lambda by 2 will be equal to our length, or we can say lambda will be equal to 2 multiplied by the length, and the length is given to us as 60 centimeter. So we can say this will be 0.6 and giving us a wavelength of 1.2 meters. So fundamental frequency that is F will be equal to our wave velocity divided by 2L, and that is our wave velocity divided by lambda. So we already know all the values, so we can say our frequency will be equal to 5, wave velocity we found out 5.85 into 10 to the power 3 and divided by lambda is 1.2 meters. So we get this frequency will be equal to 4.85 into 10 to the power 3 hertz, and we can approximate that this is equal to over 5 kilohertz, approximately 5 kilohertz. So this is the value of the fundamental frequency. This is the value of fundamental frequency. So the options that are given to us, option number B is the correct option. Option B is correct. So this question was quite simple, directly based on the formula itself. So this completes the question. Thank you.